So at this level we have 3 rules for differentiating. So we have a case where you are dividing two functions of x, where this is not a constant and neither is this. You have an x on the numerator and an x on the denominator. So when you are dividing, you use what is known as the quotient rule. Quotient. So the quotient rule is also in the form of a quotient. dy dx is defined as, you start with a v, then you write du dx, this is u, and then minus. Remember, for division is related to subtraction, so you put a minus there, and then you have u dv dx, and then everything divided by v squared. So you start with v, you end with v. You don't swap these, where u is the number, the function on top. It makes sense because these are in alphabetical order. If you want to remember them, you can also say upper, and then this one will be automatically the denominator. And then we have a case like this, where this is not a function of x, it's a constant. So on this one, you can simply use the chain rule. If you want, you can use this, it will still work, except that you waste a lot of time. So let's quickly delve into it. So find y dx for the equation y is equal to x plus 2 over x squared plus 1. So your data will be u is x plus 2, and then v is x squared plus 1. So from the formula dy dx, which is the quotient rule, is equal to, remember to start with a v, dv dx, and to end with a v squared. So from this formula, we need du dx and dv dx. So du dx is obtained from here. You can say du dx will be 1, because when we differentiate this, we get the 1. And then dv dx will be obtained from here. dv dx, this will be 2x. So now to find dy dx, you can simply substitute these things in the formula. It's that easy. So dy dx is equal to, where you have a v, you put this is your v. So you can say x squared plus 1, and then du dx is 1, minus our u is x plus 2, and then our dv dx, this is 2x. And then finally, you write the denominator, which is v, and then you put everything in brackets and square. So you can leave the denominator like this, you don't need to expand it. And then on this one, you can expand, and then expand here as well. So 2x times x, this will be 2x squared. Because of this negative, we have another negative. 2x times 2, this will be 4x. And then everything over x squared plus 1 squared. Then you can simplify it. So x squared minus 2x squared, this is minus x squared. And then 1 minus 4x, this will be minus 3x. Everything over x squared plus 1 squared. Then you can end here for B. We have find the equation of the normal to the curve y is equal to 5 over x plus 1, which can also be expressed as this. So I know it's tempting to use the quotient rule here, and yes, it can work, but it's much easier to use the chain rule, which states that dy dx is equal to du dx multiplied by dy du. It doesn't matter the order here. So with this method, you can simply find your du dx and your dy du and multiply them. So we have these numbers here. You can just say let this thing in brackets u, which is x plus 1, be u, and then your du dx will simply be a 1, and then if this is your u, then your y will be, let me write it this side, your y will be 5, and then where you have this, you can put your u raised to the power -1. So our dy du, you're differentiating y with respect to u, this will be this times this, which is -5, and then -1 minus 1, you have -2. Remember, when you are differentiating, you get the difference between the odd power and the new power, and then when you're integrating, you add. So don't mix these two ideas. So this is our dy du, and then we know, of course, du, that our u is this one here, so you can say x plus 1 to the power -2. So now using this formula, we can say dy dx will be du dx is 1 multiplied by dy du. Dy du is this. If you want, you can write it like this, and then later on you and substitute, but I'll write it like this, to the power -2. So when you expand this, you have, or maybe when you simplify it, you have this as your dy dx. So the question is saying find the equation of the normal to the curve y is equal to 5 over x plus 1 at the point x is equal to -2. So after differentiating, let me just write the data down, the data we have so far. After differentiating, you want to find the gradient at this point. By the way, just a quick look at this question. It's like you have a curve that looks like this for this equation there, and then the normal for this line, I mean the tangent for this line will be something like this, and then the gradient of the tangent line is the same as the gradient of this curve at this point. So if I was to draw a normal, remember the normal looks like this, it's perpendicular to the tangent. So the relationship between these two gradients, let's say this is gradient 1 and this is gradient 2, will be m1 by m2 is equal to -1. So let's find m1 and use it to find the gradient of m2, and then we can find this point and finally the equation. So we can say dy dx at x is equal to -2 is -5, and then -2 plus 1 raised to the power -2, then this will be -5, this will be -1 to the power -2. So when you square this, regardless of the sign there, this will simply be a 1. So we have -5 here. So the other gradient will simply be the negative reciprocal of this, but because it's already negative, the gradient will be positive 1/5. As you can see, -5 multiplied by 1/5 is equal to -1. If you want, you can substitute this in here and solve for M2. So now we have the gradient. We need a point along this line. So since we already have the equation, which is y is equal to 5/x plus 1, and we know that we are dealing with the point where x is equal to this, so we can find the y value using this x value and the equation. So this is -2 plus 1, so that our y is equal to 5/-1, which is -5. So we have the gradient and a point, which is x is -2, y is -5. Never mind my drawing, this was just a quick sketch. It needs not be accurate. So using this information, we can easily find the equation under discussion. So I will use, which method can we use? Okay, let's use this one. So our gradient is 1/5, and then our point is -2,5. So to find the equation, we can simply put a -5 on the y, and then 1/5 on the m, and then -2 on the x plus c, and solve for c. This will be this -2/5 plus c, and then we have -5 plus 2/5 is equal to c, and then this times this is -25 plus this will be -23/5 is equal to c. So the equation we are looking for is y is equal to 1/5x minus 23/5.